Section 10.1, Adding and Subtracting Polynomials. So the first part of this lesson or video has to do with what a polynomial is and some vocabulary around polynomials. That if we know this vocabulary, then when we talk about polynomials, then we'll have an easier time. So if we look at some of this vocab, the first blank here says a blank is an expression made up of the sum of terms of the form ax to the k, where k is a non-negative integer. This is polynomial. So almost everything that we deal with in math, at least up to this point, has been a polynomial of some sort, because even though this right here maybe looks weird, if we think about some of the terms that we've seen, then we might think about like a term like 2x squared. This is called a term because it's just one thing. It's got a number, an x, and an exponent, just like ax to the k does. And so this is a polynomial, 2x squared, but also if I add other things to it, like what we saw in our last chapter about with quadratics, we usually had like 3 different terms. So all of these together make a polynomial. All of them separately are polynomials. All that really matters in order for something to be a polynomial is that we cannot have a negative exponent. So it says where k is a non-negative integer. So k can be 0 or a positive number. So I can have a term that has x to the 0, which is just 1. In fact, that's what this 5 has, is an x to the 0. Since x to the 0 is just 1, we don't write it because 5 times 1 is just 5. So even just normal numbers are really polynomials if we wanted to get technical. So moving on to some other vocabulary words, a polynomial is in standard form when the exponents of the terms are in descending order. Let's see if I can spell descending correctly. I think this is it. So that is like this case up here that I wrote, 2x squared plus 3x, which would be like to the first, plus 5x to the 0. These exponents, the biggest one is first, the next biggest one is in the middle, and the smallest one is at the end, and that means that that's in standard form. So that's the form that we like for them to be in for a multitude of reasons, some of which may come up today, some of which may come up later in the chapter. But if nothing else, it's a way for us to all be able to write our answers so that they look the same, is that they're all in standard form, so it's easier to check and see if we got the same thing. The blank of each term is the exponent of the variable. This word is degree. So the degree of each term is the exponent of the variable. The degree of the polynomial, or of a polynomial, is the largest exponent of the whole expression. So going back to this example up here that I wrote down randomly, each of these terms has a degree because each of the terms has an exponent for x. So this first term has a degree of 2, and the second term has a degree of 1, and the third term has a degree of 0. So they each individually have a degree. We can also talk about the degree of the entire polynomial, which is the biggest exponent of those 3 terms, which is 2. And we'll look at why we care about degrees here in a second. If a polynomial is in standard form, the coefficient of the first term is called the leading coefficient. So you may or may not be super familiar with the word coefficient. In general, a coefficient is the number in front of x. So 2x squared has a coefficient of 2, 3x has a coefficient of 3, and 5's coefficient is 5. But the leading coefficient is the very beginning, if we're in standard form, the very first coefficient we have, which in this case would be 2. One of the things we're going to do with this is we have words to name polynomials, which you may have seen before, and one of the ways we can name them is by how many terms they have. So a blank has 1 term. That is a monomial. you've probably heard the prefix mono before, and that is generally used to mean 1. So then if we know that that's what one term is, and we think about our prefixes for 2 terms that might happen, we might be able to guess what the second one of these is. It's a binomial, has 2 terms, and the same thing with 3 terms. If we know a prefix for 3, we might be able to guess this one as well. That's an extra N. This one is trinomial. The degree is another way that we can classify our polynomials. So a lot of times we'll call polynomials by a combination of these 2 things. So if we have a degree of 0, which means that we just have a number, then that is called constant. That is a constant, and it'd be a monomial, because the only way we can have a degree of 0 is if we only have one term. A degree of 1 is called linear. And so we could think about, if I have a degree of 1, that's something like this, maybe 2x plus 3, where our biggest exponent is this x to the first. And so that looks like the kind of equations we had that were linear, just it's not actually an equation because it doesn't have an equal sign. So if we think about things that have a degree of 2, which this was the last chapter that we talked about in my particular class, this would be quadratic. And if you're going through Algebra 1, then at this point that's probably as far as you've gotten before, is talking about these 3 types of equations or graphs. And so whenever we look at these last 3, these words may not be as familiar. The word for 3 should be familiar because a degree of 3 is called cubic. Well, maybe not cubic, but like we cube things whenever we raise them to the 3rd power, so it shouldn't be completely foreign to us. 4 is called quartic, so if you think about quarters, that's where that prefix comes from. And then 5, if we can think of a prefix for 5, we might be able to guess this, it's quintic. And then after that, we just normally don't even bother. Like you could probably come up with, in a similar fashion, words to mean a degree of 6 and a degree of 7 and so on. But for one thing, those types of expressions just don't come up as much. So there's not really necessarily a need for us to name them, but also it's just kind of silly to have a name for everything, I guess. So we just, if it's bigger than 5, we would just say it's like a 6th degree polynomial or a 7th degree polynomial, and we wouldn't have a specific word for it. So in this example, we're just going to identify the leading coefficient and then classify the polynomial by degree and by number of terms, starting with a here, 4x plus 3. We want to check and see if this is in standard form. So that means that the exponents for our x's are in descending order. This has an x to the first. 3 doesn't have an x, so it's like having x to the 0. So yes, it is in standard form. That means that the very first number is the leading coefficient. So our leading coefficient for this one is 4. If it wasn't in standard form, we would rearrange it into standard form so that we could see what the leading coefficient is. If we classify this by degree and by number of terms, the largest exponent is 1, which means that this is linear. There are 2 terms here. This is our first term, and this is our second term, and so that makes this a binomial. So together, that makes this a linear binomial with a leading coefficient of 4. On part B, this is not in standard form because our biggest exponent, which is a squared, is at the very end. When I rearrange this into standard form, I take the sign that's in front of whatever my term is with it. So this is not just an x squared, it's a negative x squared. It's not just a 2x, it's a negative 2x because of the negative in front. And the 7, which doesn't have anything in front, is a positive 7. So now we've got squared first and 0, so it's in the right order. That means our leading coefficient is what's in front of x squared. Since there's not a number there, but there is a negative, that means -1. Our largest degree is this squared, and squared means quadratic. And then it has 3 different terms, so this would be a trinomial. C only has 1 term, and so it must be in standard form because there's no way to rearrange it. That means that the 9 in front is our leading coefficient, and our degree, which is 4, makes this a quartic monomial. Monomial because there's only 1 term, quartic because our exponent is the 4th power. On D, more than 1 term, so let's check and see, is this in standard form? Which it is not, because the 3 is second instead of first. So we would just flip-flop these, since there's only 2 of them. And so the leading coefficient is the 10, and the degree is 3, because our biggest exponent is 3, so that is a cubic. There's 2 terms, so that's a binomial. And then finally, all we have here is a 6. That's like having an x to the 0 next to it, because there are 0 x's next to it. And so that means our leading coefficient is just the number that we have, which is 6. That means its degree is 0 because it doesn't have an x, so it's constant. And there's only 1 term, so that makes it a monomial. Now one of the reasons we name things in this way is because each of these things, if we compare it to other polynomials that have the same name, they will potentially do similar things if we put them in an equation or try to graph them or things like that. So any linear binomial that you have will be a line if we put a y equals in front of it and decide to graph it. Or any quadratic trinomial, if we put a y equals in front of it, we'll have similar things happening. And the leading coefficient ends up telling us a lot about that graph, and so does the fact that it has a degree of whatever it has. The number of terms is not quite as important as far as our graph goes, but it does have an effect, but it's not as clear. What really is clear is what's happening because of the leading coefficient and the degree. And so later on in your math career, if you're an Algebra 1 at this point, you will look at what impact the leading coefficient and the degree has on a graph. It'll be totally awesome. So what are we going to do with these polynomials? Just like we can add and subtract numbers, we also can come up with a way to add and subtract polynomials. And not only that, we can also multiply them and divide them, and that's going to come later on in maybe this chapter, maybe later on in life. But right now, we're just going to stick with adding and subtracting. And the most important thing to remember when we add and subtract polynomials is the idea that we have like terms and unlike terms. So an example of like terms right here is 3x cubed plus 5x cubed. These are like terms because they both have x cubes. And so this is like saying that I have 3 apples plus 5 apples, and I'm going to get 8 apples. But instead of having apples, I had x cubed. So it stays x cubed. We don't change it to x to the 6th or anything like that. That's not how it works. The reason behind this is because x is really some number that we don't know. So let's pretend that it's a 2 cubed or something like that, or it's a 2, that x is a 2. If we wanted to do 3 times 2 cubed plus 5 times 2 cubed, the question is, do those add together and make 8 times 2 cubed? Is that what we're allowed to do? And it turns out that that does work. We would do 3 times 8, which is 24, and we do 5 times 8, which is 40, and that would give us 64, which if we work this out, 8 times 8 that is 64. So this really does work, that even if I put in a number for x, it still works to be able to add in this way. The problem is that that doesn't work if our terms are not like. So here I have 2x cubed, here I have negative 4x squared. Those are not like terms, because having 2 times 2 cubed, for instance, minus 4 times 2 squared, this is 2 times 8, which is 16, and this is 4 times 4, which is 16, and I subtract those and I get 0. So how would I have guessed that that's what would happen if I have x's instead of 2's? That's not how that works. Okay, so what matters is that we have the same degree on our x's. That means that we can add or subtract what we have. Now there's 2 methods for us to use to help us add and subtract. One is called the vertical format, and one is called the horizontal format. The vertical format is reminiscent to us adding, when we started adding like 2 and 3 digit numbers together back in the day. Usually we'd put the longer one, if that's possible, first, or on top actually, because it's going to be vertical, which is up and down. We go ahead and write that down, and then underneath that we're going to write the second polynomial, but we're going to do it in such a way that our terms match up. So the 2x doesn't go at the beginning, it goes underneath the negative 5x, and I'd put a plus because 2x is positive. The negative 7 goes underneath the 8 because those will be like terms. The 3x squared goes underneath the 7x squared. And the negative 4x cubed goes under the other negative 4x cubed. So what we just did is we actually put the second one into standard form while we were at it. And then now we're ready to just add vertically like we do with numbers. We can do 8 plus negative 7, which is a positive 1. We can do negative 5x plus 2x, which is negative 3x. We can do 7x squared plus 3x squared, which is 10x squared. Negative 4x cubed plus negative 4x cubed. Those don't cancel each other out. They are both negative, so we add and keep the sign. This x to the 4th doesn't have anything to add with, so it just gets to drop down. And so this would be our answer. I highly recommend the vertical format because it makes it really easy for us to tell at the beginning what our like terms are and what they are not. The other way that we can do this is called the horizontal format. And so what that means is that we look at our terms in each of them kind of on a case-by-case basis. Like we look at the x to the 4th and we say, oh, it doesn't have anything to add with. Then we look at the x cubes and we put the x cubes next to each other. And then we're going to take the x squareds and put them next to each other. And then we're going to take the x's and put them next to each other. So I'm doing the exact same problem again, just writing it differently, thinking about it slightly differently, but I should get the same answer. And last we put the numbers together. And so the same thing's going to happen that happened in the last problem, like that the x to the 4th doesn't have anything to add with, that this becomes negative 8x cubed, this would be 10x squared, then negative 3x, and then positive 1. We get the same thing. We wrote it out differently, but we had to do the same thing, basically. So it's kind of up to you, or maybe your teacher, which you would prefer to use. Like I said, there is a strong advantage to the vertical format, but if you would prefer to use the other format and your teacher doesn't mind, then go for it. So let's do some more examples. So one of the things here, because we are going to be adding and subtracting, is to take a note at the beginning of the problem of whether it is addition or subtraction. This is an addition problem because it has a plus sign in between our parentheses. And that means that we'll just take these terms and write them out and add our like terms together. If it was a minus sign, we'd have to worry about subtracting what's in the second parentheses, which we'll see in a second. I'm going to use the vertical format. And so when I do that, when I write out the first one, or if that's the one I choose to start off with, I would have to be careful because we have 6x cubed, but then we don't have an x squared or an x So really -2 should go after a pretty big gap. Alternatively, I could have started with the longer one on top, and that would work. Because, yeah, never mind. But basically, we're leaving space for x squared and x. I have 7x squared, which would go right here. And I have a 7x cubed, which would go under this x cubed. I have a +5, which would go right here. So there weren't any just x terms. So that's why this gap is here. We don't need to leave that gap there for our answer necessarily. We would do -2 + 5, which is 3. 7x squared doesn't have anything to add with, so it stays 7x squared. And then 6x cubed plus 7x cubed is 13x cubed. So that would be our answer. So what's different when we subtract instead of adding? What happens is that this negative is going to affect everything in the second parentheses. It's basically like we're distributing a -1. And so we can start this off the same way, where we write out the first one or the longer one. And then when we go to write the rest of this, every single one of these is getting multiplied by a -1. So I'm not going to have a positive 5a, I'm subtracting 5a. I'm not going to add 6, I'm going to subtract 6. And I'm not going to add a -2a squared, I'm supposed to subtract a -2a squared. If I subtract a negative, that's really like I'm adding. So every sign has to change. When I write this out, I should see that each of these three things have a different sign than what they started with. And then I just go through and add. And since there's no carrying here, I actually could add from left to right if I wanted to, instead of from right to left like we're used to doing. So my answer is 6a squared minus 12a minus 8. And this is a final example, so if you feel like you've got the hang of this, pause the video and give it a try on your own, and then start the video back up to see if you got the answer right. This is a subtraction problem, so everything in my second parentheses is going to be subtracted, which is going to change the signs. When I write out this first one, I'm going to put it in the right order. I'm going to think about whether or not things are being skipped, which it doesn't look like they are. So when I put 3v, I have to subtract 3v. So I'm going to put minus 3v. I'm going to subtract a -8v squared, so that's really adding 8v squared. I'm going to subtract 8v cubed. So like I said, I can go from left to right because I don't have to worry about something being carried like I do in normal addition. -4 plus -8 is -12. 3 plus 8 is 11. 2 minus 3 is a -1, but we don't need to write the -1. If you do, that's fine. The 8 is just going to drop down because it doesn't have anything to add with. So this is our answer. This has been an introduction to adding and subtracting polynomials, as well as an introduction to the vocabulary we use when we're talking about polynomials. So thank you for watching.